Find the volume of the solid generated by revolving the region enclosed by the graph of y equal e to the power x over 2, comma, y equal 1 and x equal ln 19 about the x-axis. So as you can see, this is the problem from section 6.2. I think it's number 17. As you can see, here is no example, but you can always try the previous problem or next problem, the very similar type of problem with the examples. Okay, anyway, so this type of problem you always have to try to draw the structure or region you are working with. So here you can see that we are looking for the region enclosed by y equal e to the power so let's say this is the x-axis, y-axis, and we are looking for okay, so y equal, this is y equal e to the power x over 2 and y equal 1, because this graph is going to intersect at 1, so this is y equal 1 as well, and then finally x equal ln 19, so somewhere here that's greater than 1, so x equal ln 19, right? Okay, so the region enclosed by this is this one. This is the region we're looking here. So remember, this is the point where you have x equals 0 and y equal 1. This is the point where you have x equal ln 19 and y equal e to the power ln 19 over 2, which if you simplify, if you plug e to the power ln 19 divided by 2, which is e to the power ln 19 to the power half, because of the power rule we can always bring this half there, and this e and ln will be cancelled out, so it's basically square root of 19. So it's a square root of 19. So now, as you can see here, so if you take a slice of this enclosed region, this is the enclosed region, everything from here to here, everything. Okay, and we want to find out what is the volume generated by when this enclosed region revolves around this x-axis. So what we do is we take the piece of it like this one, okay, and then when this piece revolves around this x-axis, this is the structure you might be able to see. You can see here, maybe it's not perfect one. Let me try to make it a little bit better. So when you revolve this slice, this is the structure you are going to get. Okay, and this structure, it's you can see that from this point to this point, here you have a radius of a smaller circle, and from this point to up until this point, that's your radius of the bigger circle. So there are two circular region you will be able to see, and if you subtract the area of a smaller circle from the bigger circle, you are going to get the area of revolving by this small portion. So that's where we're going to use as you can see here, this washer method. If a typical washer has an outer radius Rx, which means as you can see in this picture, they are talking about the big circle with radius capital R, and then a small circle with radius small r, then we can find the volume by using this formula, which is pi a to b r square minus r square, where a and b are the range of x. In this case, a means the smallest value of x, which is x equal to 0, and then b means the largest value of x, which is x equal to ln 19. So it would be you need to find out the radius of inner circle and radius of outer circle. As you can see, that radius of inner circle can be found by from here to here, the distance is y equal to 1. So that's your small r. and the radius of the outer circle is from distance from here to here, which can be found by y equal e to the power x over 2. That's the value of any point on this curve. So typically the volume would be from pi from 0 to ln 19 capital R square, which is e to the power x over 2 whole square, which is eventually e to the power x, minus small r, which is 1, so it's 1 square. So e to the power x over 2 whole square is e to the power x only. So now you have to integrate by using fundamental theorem, and this is pi, the integration is e to the power x minus x 0 to ln 19, and if you plug the value of x as ln 19, it would be pi e to the power ln 19 minus ln 19 minus e to the power 0 minus 0. So eventually this is e and ln inverse, so it's 19 minus ln 19 minus it's 1. So eventually this is pi 18 minus ln 19. So I'm going to type this here, pi 18 minus ln 19, and that's the answer.